Hello class, Mr. Knight here to give some insights for lesson 2. Now, these insights will be broken apart into two different video segments. In the first one, I'd like to give a recap of Lab 1 from lesson 1, as well as talk a little bit about Pythonic Code. The second video part will be more about lesson 2, which will be software testing focused. So let's recap on Lab 1. For Lab 1, we had to write two different programs. One that would calculate your average or your grade for the class, and the other one which would calculate retirement age for Social Security. Both of these were meant to be kind of a review on Python, but it was important that we got these right because we're going to be using these programs for testing in a few labs to come. So overall, submissions were pretty good. The median score was an 85, which is right in the middle of the B range, so good job everyone. Just a few pieces of feedback for the entire class so that we can all do a little bit better. And also some things to help out me as your instructor. Please make sure you read the instructions very carefully. When we say we want things like separating inputs from calculations, that's important for a reason. Also, it's very, very important not just to have a working solution when it comes to your code, but to have good code, following good practices. In the real world, these programs will probably be living much longer and they're going to be much bigger and much more complex. So it's very, very important that you write good, maintainable code that other people can jump in and understand. Things that will be scalable, things that separate concerns, things that have sensible function names or classes, but also aren't overly complicated either. So even if you felt like your solution may have worked and it may have kicked out the right answers, if your code wasn't as good as it could have been, you may have lost some points. So keep that in mind as you move forward with future labs. What you write actually matters. So just a few things I want to shout out real quick as far as submissions go and as far as writing good code go. Please do not include your virtual environment directory or your .idea directory when you zip up your solution and submit it to Dropbox. It adds a lot of extra size that is unnecessary. For these activities, since usually the labs are going to be pretty small, I just need the Python code. I don't need all the extra stuff that comes with it. Also, please always validate your inputs. Whenever somebody enters something at the command line, make sure that you have some sort of validation check to ensure that it's okay. Now that wasn't necessarily an explicit requirement of Lab 1, and so I didn't knock off points for those who didn't validate, but I'm going to ask as we move forward, all lab assignments from here on out, please validate your inputs appropriately, because if you don't and there's a problem, then I will have to start marking points off. Input validation is just a safety mechanism, right? It protects your code from doing bad things. Also, as we said before, make sure you always separate any of your input and output stuff from your other logic, right? It's a separation of concerns. Whatever interfaces with the user at a command line should be separate from whatever calculations or logic is done on the back end. Hard truth, print statements are rare in the real world. Unless you're doing a lot of command line tool development, you're not going to be using a lot of print statements aside from maybe debugging or helping as you go. Right? Those functions that calculate things like your grade or that calculate things like retirement age for Social Security, what they should do is they should take in inputs, do some calculations, and return objects or values. They shouldn't be putting print statements in those functions as well. What should happen instead is the caller will receive whatever calculated value and then as a separate concern, determine how that should be handled. Should it be printed to the screen? Should it be returned as part of a REST API request? Should it be spit up on a web page? Or is there some should be logged to a file? Right? We don't want to couple the outputting from, or we don't want to couple the outputting with the calculation. Those should be separate concerns, and we should have separate functions or classes or methods to handle them. So just watch out for that. And finally, another thing I saw is everybody had a different way of having their main body executed. Some people just wrote statements directly in the Python module, which works. Some people put them in a main function and then called the main function at the very end. Some people had variations of that. So what I'd like for us to do as a class is to standardize on a better way. I'm going to put that in an announcement in Blackboard. Basically, we're going to be checking if dunder name equals dunder main, and then putting all of our main logic in there. That will protect it from, if we wanted to turn that Python py file into a module that's imported somewhere else, that statements wouldn't just be executed and stuff is printed to the screen unexpectedly. So stay tuned for that. Please do that in the future every time we have mains now. So I hope all of that made sense. So just other things about the labs, lab 2 is coming up. It's going to be due this coming Thursday. So please be proactive, not reactive. If you hit trouble early on, please reach out to me early rather than when it's too late. And knock it out of the park. It should be another fairly simple exercise. This time, the trick is going to be it uses some lists. So you're dealing with collections now. So good luck with that, y'all. I look forward to seeing your submissions. With all that lab stuff out of the way, since we're on the topic of Python code, I want to talk about what it means to write good Python code, or Pythonic code. There are many programming languages available. I'm guessing many of you may have some experience with Java, maybe a few with C#, maybe some JavaScript as well. But it can go from there. There's like C++, Ruby, Perl, you name it, it's out there. A lot of them are similar, a lot of them are different. Python itself is very highly opinionated. When people tend to write code in different languages, there's definitely a sense of having the right accent. I can relate this to real life. My wife is from China. Her native language is Mandarin. Her second language is English. And so she always speaks English with a slight accent. Likewise, when I try to speak Mandarin, my Mandarin is pretty bad and I sound like an American. But what we want to do is we want to be as native in our language usage as possible. And that's true of programming languages as well. It's fairly obvious when you see somebody who's historically a Java programmer start to write Python code, because you see a lot of things that are very common in Java written in Python, but there may be better ways to do things in Python. And that's where we get this notion of what we call Pythonic code. What we're talking about with Pythonic code is idiomatic Python. The way that most programmers who really use and love Python think is the right way to do it. Usually that's things that are concise, using parts of the language like operators and commands that may be special to Python that aren't in other languages, that make things easier in Python. Things like being explicit rather than implicit, things like readability counts, all these kinds of characteristics that make Python code more readable, more understandable, and ultimately just better. Now, you don't have to write your code as Pythonic code, but it helps because other people in the world, like myself, who are Python programmers, when we come to Python code, we expect things to be written in a certain way. And that helps us to better understand your code and possibly contribute. So writing Pythonic code is a very good thing to do. So I'm going to give a few examples of what that looks like. And also I'm going to put another post in Blackboard in the announcements with some links that you can read up on, as well as all the stuff I'm about to describe, including a link about what does it mean to write Pythonic code. So first of all, in Python, we have this thing called PEP 8. PEP 8 is the standard style guideline for writing Python code. Because Python uses white space, because there are no semicolons, it's important that we have good style guidelines so that our programs will actually compile and work. The PEP8 document is very, very, very long. But most IDEs like PyCharm will point to you and tell you when you're in violation of a PEP8 standard. Furthermore, there are also tools that can help enforce your usage of good PEP8 standards, one of which is called BLACK. BLACK is a formatter. It's an opinionated formatter. What it does is it will take in your source code, reformat it, and spit out a new version of that file. The logic of the code and the commands of the code are going to be all the same, but they'll just be adjusted space-wise appropriately. I definitely recommend checking it out. It's a fairly new project, but it's become very, very popular very fast. It was all the rage at PyCon 2019 this past year. So it could just be an extra step in your workflow that right before you submit your assignments, you run your code through BLACK, makes it nice and pretty, and then that way it's readable and everybody can understand it. Some other things I noticed would be the case used for lettering, right? In Java, it's very common to use UpperCamelCase, where you smash all the words together and the first letter of every word gets an uppercase character, while as the rest of that word gets lowercase. And then the next word will jump up to an uppercase again. Some people use all lowercase, straight across. In Python, it is Pythonic to use what we call lower snake case for variable names and for function names and for method names. What snake case is all lowercase, but words are separated by an underscore. However, for class names, it's a best practice to use UpperCamelCase. Why that is, it's just the way it is. It's evolved that way. But that's kind of like the best practice when you're writing Pythonic code. So you don't have to use snake case and you don't have to use UpperCamelCase. But what I would recommend is that you use them like most other Python programmers use them. Some other good things I might just want to mention. In Python, not everything needs to be a class. That's very nice and very helpful. Object-oriented programming is a wonderful paradigm. It helps us with modeling objects very well. It helps us with reusing code. It lets us use amazing design patterns. But it's not a one-size-fits-all, right? We don't need to put everything into a class because sometimes that's overkill. Sometimes it's appropriate just to use simple functions, as is the case with these two past lab exercises. When I coded up the solutions myself, I didn't use classes. I just used functions. Functions can be stateless, which is really nice. You don't have nasty side effects. They're simpler for more people to read and understand. They are more shareable, right, because they're less complex and they're smaller usually. So just keep that in mind. Functions are a good thing, right? There will be times where we need to write classes, and that's okay. But typically, I prefer to write functions when I can and classes when I must. And Python is wonderful because it gives you the options. You can do either or, right? Unlike a language like Java or C#, where pretty much everything is a class. You don't have a choice. So keep that in the back of your mind. Simple is better than complex. Complex is better than complicated. I'd also like to shout out, comments are good. Helpful comments are even better. I like to think of my code when I write it in terms of paragraphs, right? Just like when I would write a letter in English, I'd have a couple sentences as a paragraph that has a main idea, then I have another paragraph. I like to do that with my code. Within, let's say, a function should be one paragraph. Or if it has, multiple segments in it, maybe those could be smaller functions. And so I can stack up my paragraphs as I write my code like this. And each paragraph ought to have maybe like a one-line comment saying, hey, this is my intention with this. I'm going to read in all the inputs for my grades. Or in this paragraph, I'm going to calculate the weighted average and return it. So giving those comments at that level as an Englishy way to say, hey, this is what's going on here, or this is what I intend to be going on here. That can help others come in and read it and pick it up and say, oh, got it, that makes sense. So I would encourage you, Write good comments where appropriate, because it'll help you think and it'll help others read. And finally, one other thing I'd like to say about about Python and Pythonic code. In Python, there's something called the Zen of Python. You may or may not have heard of it. What the Zen of Python is, it's a set of 20 principles that guide the development of the language, as well as how we ought to program using the language. You could Google Zen of Python and it'll come up. Or if you're at your command line, if you enter the Python interpreter with the Python command, and then you type import this, you'll see the Zen of Python print out. So I would recommend everybody as like an off assignment, just go try that. Run the Python interpreter, import this, and read through the Zen of Python. And you'll see the opinions that help to guide the language. And you'll see some very, very helpful advice also for how you can write good Python code. And not just good Python code, but just good code in general, because many of those principles aren't limited to the Python language. So that's all for part 1 of the Mr. Knight's Insights videos for lesson 2. I hope that was helpful. As I said, I'll post all that Pythonic stuff up on Blackboard so you can see it. And good luck with lesson 2's lab assignment. And check out the second part video coming up soon.